Remember, if I want to solve equations, I said for the most part, right, we can use the same process as normal equations. You just want to think about opposite operations here, right? Right now I've got minus 3x is greater than 9 here. So Eva, what would be the opposite operation I want to be thinking of?
Divide.
Right, because I've got minus 3 multiplied by x. I want to get x by itself, so I want to divide both sides by negative 3, and that's exactly what I'm going to do. I'll just get x on that left-hand side. 9 divided by negative 3, I just want to be careful. I know a positive divided by a negative. I'll just get left with a negative there, right? But remember, what's the rule when I divide by a negative value? I switch the sign, right? So now my x value is less than negative 3. It's less than negative 3. It's quite simple, yeah, not too bad. And it's the same idea, it doesn't matter what inequality sign you're using or what values you're using. Anytime you multiply or divide by a negative number, you need to apply this rule here, right? So even this one, negative 4y less than or equal to 16. Maddie, you can help me out? What should I divide both sides by?
By negative 4.
Good, awesome. So I've got y on this side, and I've got negative 4 on that right-hand side. But remember, you've got to swap the inequality symbol, okay? So we've got y is greater than or equal to negative 4. And you can check these really easily if you just substitute some value back in. Because remember, with inequalities, it's saying that all the solutions that are bigger than or equal to negative 4 will match this in. So if you substitute negative 4 back into that, you'll get negative 4 times negative 4, which is 16. And that means that inequality symbol is true. That's one really easy way to check. Chloe, what did you realize with this third one here?
That there's no negative.
Okay, the reason why I put this one in is...
It's a trick.
Yeah, it's a bit of a trick question because you've got to realize this only applies if you're dividing or multiplying by a negative number. And sometimes they'll combine positives and negatives in there to trick you. So just remember, okay, since I'm dividing both sides by a positive number here, Mick, what would I divide both sides by? Yeah. You just get n is less than 5. There's no need here. There's no need here to swap the inequality symbol. You can just do it as per normal. Okay? With equations, right, we always have lots of different options. I can do certain things first. I can multiply things. I can divide things. And you probably want to find the way that's most comfortable for you. In this case, again, you have a few options here, right? You can see that there's a 5 on the denominator. So what would the opposite operation I'm thinking of be? Chloe?
No, I have a question.
Can I do this one first?
No, it's about it.
Okay, yeah, sure.
Is the whole fraction negative? Is the 5 negative?
Okay, so typically in your textbook or in like worksheets, they'll write it like this, okay? And it doesn't matter whether the negative's on the numerator, on the denominator, or just where the line is, they all mean the same thing. And you can check that by putting in a fraction in your calculator. They all mean the same thing. So that's why I mean you have multiple options here. I'm just going to see that there's a 5 on the denominator. So I'm going to multiply both sides by 5 because it's an opposite operation. I get negative 6a is greater than or equal to 60. So here you notice that I multiplied by a positive number. So I'm not going to change the inequality symbol at all. But Maddie, can you tell me, how can I get that a by itself now?
5, 65.
Yeah, so here's where you want to use that negative operation here. You're thinking, I want a by itself. I've got a negative 6 at the front, so I want to divide both sides by negative 6. So remember, positive divided by negative, I'm going to get negative 10 there. We reverse it, right? We reverse it, so here it's greater than or equal to. Sorry, Laura, you had a question.
Why did you reverse it?
Yeah, so the rule is, if we multiply or divide by a negative number, then we reverse it. So here I multiplied by 5, that's just a positive number, I'm not going to reverse that. Any questions on that one there? That's how you can get a by itself. And again, it doesn't matter year 10, it doesn't matter what expressions you have, you always want to think about opposite operations. And I've got all these numbers here, Joel, what's the first step I could do with this expression to help solve this?
Yeah.
What can I start with?
Minus 4.
Let's just minus 4 from both sides, right? I want to get that variable by itself. I'll subtract 4 from both sides. So in this case, I get negative 12 here. So I've got that variable by itself now. Again, I'm just thinking about opposite operations. I want to get that x by itself. So again, I'm thinking about dividing both sides by negative 3. I've got x here. But remember, I've got to swap that inequality symbol if I divide both sides by negative. So you should get positive 4 then. Okay. Alright, last one. Amelia, can you start me off with this one? What would I do here?
Would you minus 2 for both sides?
Yeah, right. You want that variable by itself. So any numbers here, I just want to get rid of, right? I want to put to the same sign as the other numbers. I'll minus 2 from both sides. Again, not swapping the inequality symbol. Why?
Because you haven't done negative.
Because I'm not dividing or multiplying. It's only when you divide or multiply that you have to do it. If you're subtracting 2 from both sides, that's fine. You can do it as per normal. Angus, last step for me. What do I need to do? Yeah, right. Opposite operations, divide both sides by negative 4. That will mean I'll have n by itself. But then what I have to do, I've got to reverse the sign. So then you get, yeah, negative 1. So positive divided by negative, you end up with a negative value.